Hey everyone, so welcome back to another video of our data engineering project series, and in today's video as well we are going to implement end-to-end data engineering project starting from problem statement to the architecture design and then the complete implementation of it. And this is going to be about the real-time data pipeline, which is the most common thing to implement. And based on my interview experience in last 3-4 years, in the design round of your data engineering interviews, companies have started asking questions mostly around the real-time streaming data pipeline. So make sure your fundamentals are really strong along with the practical implementation, and this project is going to help you, and you should add this project in your resume to get the better opportunities. We will be building this pipeline end to end on the GCP. We will be using services like the data flow, PubSub, BigQuery, and the dashboarding part of it. And this is going to be a very common use case which you might have heard, like the CDC event, how to process the events coming via change data, capture from a database or something in the real time, and how to process it, doing the transformation and dump them into the data warehouses. And we are going to take a realistic domain example like booking platforms. So in India, you know, IRCTC. So this is the kind of example we are going to take. We will be mocking up the things and we'll build it end to end. So make sure you do it along with me and implement this project, and all the scripts which are needed and plus the dataset, you can find that link in the video description and you can execute it, you can run it. Plus let me know in the comment section what other project idea do you have, or any specific tech stack or any specific tool tech framework you want me to cover. Let me know in the comment section. I will build a project around that and we'll put it here. Plus like it in the big numbers so that we can help other aspiring data engineers as well. If you are new to the channel, don't forget to subscribe and press the notification icon to get these amazing projects. And a really important announcement for all the aspiring data engineers. So if you are someone who want to become a data engineer, want to crack your dream job with their dream package and a dream company too, and still struggling that what is the right approach to prepare, how to acquire the most demanding tech skill set, then don't worry, I am here to help you with my platform Grow Data Skills, where I have started the new batch of data engineering bootcamp with AWS. This is going to be a 3 months of bootcamp, that too complete live classroom environment, and you will be learning the complete data engineering from basic to advanced in just 3.5 months without any prerequisite, just the basics of Python. That's the only demand of this bootcamp, and you will become a top-notch data engineer really soon. So in this bootcamp, I will be starting the things from the SQL, Hadoop, Hive, NoSQL databases, MongoDB, Cassandra, Airflow, data warehousing, data modeling, Databricks, Snowflake, dedicated AWS, BigQuery, Flink, Iceberg, Hoodie, which are the new edition of this particular bootcamp, and more than 15 plus industry grade projects we are going to cover from the scratch. And this is the best thing you can add in your resume to get shortlisted for any big company interview. The link is given in the description, or you can visit www.growdataskills.com to join my bootcamp. And you will be getting dedicated placement assistance here in the private Discord community where you can ask your offline doubts. Plus I also take the live doubt session after each live classes, and here we are help you with tons of job opportunities, dedicated interview preparation guide, quizzes, tons of assignments, their solution, case studies, and so many things with the resume building preparation and the LinkedIn profile making things. So this is what you are going to get at very tiny cost. So what are you waiting for? Join it today and learn data engineering from basic to advanced in live classroom from me. So first project one, you can say that real-time ticket booking data sync to BigQuery. Idea is gonna be very simple. That first, what we will do, that we are going to have our PubSub. right? Let's say named as okay, and we will have a Python script. So here use cases could be anything, right? There could be n number of use cases. So this one I'm talking about is also a most common one, right? Where you Python book, a Java-based microservice application, or a backend API. Am I audible properly, guys? Looks like there was a internet. It was not stable. Okay. Yeah, so that's what I'm saying. There could be multiple use cases there. Data is getting published into the PubSub and Kafka or anything. I'm talking about a very general scenario. And also one of the important use case, right? And we will implement that one end to end in the Azure project itself. But here I'm giving you the idea. So one of the examples could be where you are receiving the CDC data, right? So when you basically talk about the change data capture, so imagine you have the NoSQL database or a SQL database. So there are the you are doing the data ingestion, like continuously you are inserting the data, updating the data, deleting the data. So every time when you are making a change to a particular record, those changes should get captured and should get published somewhere to maintain the trail of all the things you have been doing on the source data, right? So that is also one of the very important use case when you will see even in the design rounds that is being discussed very frequently. And we will implement that in the Azure. We will have our Synapse, Azure Data Factory and all those things, and the SQL servers. So we will try to replicate that one, that if we are doing the CDC kind of, we have to build CDC driven pipeline, right? So how we are going to do that? Okay. So same thing here. Either you can imagine that you are publishing something like this here in the PubSub, or instead of PubSub, you have the Kafka. Ultimately, you need some sort of queuing system in between to hold your real-time data, and from there you can do whatever you want. So here I can mention like the CDC data. That could be another way. Okay, another option. So this one we will be publishing from the Python script PubSub. We are continuously publishing, and after that, what we want this data to get continuously synced into the BigQuery, right? So that is the thing we would like to do, and for that one, what we are going to bring in between, we will have the data flow. So data flow is another service basically. Data flow, another service in the GCP, which basically helps you to move the data from A service to B service, right? In the GCP, or here, those things can be other sources and destination as well, like MongoDB, Kafka, and any other sort of thing, from where you can read the data and you can dump it into the BigQuery. You can read it from the BigQuery and dump it into somewhere else, and not just BigQuery, other services as well. Let's say you are getting the data in PubSub, you want to ingest in a big table, right? Or GCP storage or any other thing. So that is the kind of service data flow is. It comes up with the, you can say it comes up with some boilerplate code as well. A code as well, I mean to say the templates, inbuilt templates for most frequent use cases. So there you just need to configure right? You need to configure what your source destination, and your job is done, right? Nothing apart from that you are doing there. Apart from that, what it uses behind the scenes, right? It basically uses Apache Beam. Under the hood, it uses Apache Beam, which is another like framework for stream and batch kind of data processing. So it uses that one. So from the UI, you are just configuring, and behind the scenes, it has all that ready-made code, which is just helping you to doing this data sync. Okay, so that's how data flow is going to work. Same for the batch one. It's not like the only streaming one. It can do that. It can do your batch data transfers itself. And in between, you can do some sort of transformations, right? So first of all, the purpose of data, if you, let's say, basically compare it with the replacement of something, some distributed framework or something, no, it's not like that. It is more onto like heavily used for the data sync and that kind of data ingestion part, right? If you have very challenging transformations and other use cases, this might not be a useful thing for to do that. You have to write a custom code something. And plus here, with the data flow itself, by any chance, right, if you are not using the template code, you want to do it from your side, so you have to write your code in the Apache Beam itself, right? And then you need to make it available there, so that whole lineage and all that part is created. Okay, so I will show you like how we will be using the template one. I'll show the option, right? What are the options we need to create, we need to set up when we create the batch, when we create this type of streaming flow pipeline, where we are syncing data from the pub/sub to the BigQuery table. In between, how you can write the Python UDF, user defined functions, to transform your individual records. Okay, and after that, if your ingestion is getting failed, how you can apply the dead letter queue, so that your failed records are written somewhere else, all that part. Okay, so in between we have the data flow, and here you can say that we will have our BigQuery. Okay, so here we are reading it. What will be done here? Read from pub/sub. And apply Python UDF for transformation. Uh, any fault tolerance probably. And then write. Okay. And how it is going to apply the Python UDF, how we are going to provide the code to that one. So what we will have, we will basically have the GCS bucket, because it is a Python code. Basically, it is a Python code which it needs to look at, it needs to use. Okay, so that's what will be there. Data flow, Google storage bucket, right? So here you can have your maybe transform udf.py, right? So when we are saying apply Python UDF for transformation, means data flow will actually register that UDF by reading it from here. Okay, so this is how it's gonna look like, and now let me show you that how it is going to work. So I had a different project for it. Okay. So before going on to this part, right, like working on the PubSub to the BigQuery related thing and the data flow, right? So here I have opened this thing to be bucket, and then I will open BigQuery here, and then I will also open the data flow, right? So initially when you will so for like to work with the BigQuery, I told you in the beginning that you actually need to enable the BigQuery related API. As soon as you search for it, it will automatically ask you to enable the API, right? So you don't need to remember anything, what API you need to enable, something like that. Same thing here as well. Once you get started with the data flow, it will ask you to basically create the kind of enable the APIs, and then you will be able to use it. Okay. So that is the thing here, and our BigQuery table. I will show you the data, how our data mock script, first of all, how our mock script looks like, how we are going to process it, all that part. And before that, I have this table. So let me let me come here. Hmm. Yeah, so what you need to do initially, the permissions related part. So in this whole project, right, what all services we are going to interact with? We are going to interact with the PubSub. We are going to interact with the BigQuery. We are going to interact with the data flow. So first of all, you need to make sure that the kind of service account you have in your IAM role, basically, right? In your IAM role, you basically need to enable these things. That's the important part here. So all these kind of roles, so you need to make sure in your IAM service, whatever service account you have, okay, imagine this service account we have. So you can see BigQuery admin, data flow admin, PubSub admin, right? So these kind of permissions you need to add as a role in the service account so that you can work with these services seamlessly. Else, while deploying your job or while executing your data flow job, it will give you some errors, right? It will throw the errors. Sometimes, let's say, even after adding, although you should not face any issue after enabling these APIs or after adding these roles. But by any chance, if you face it, so in the error message, whatever services it asks you to add, just you can simply add those one in the role and it will work, right? There shouldn't be any issue at all. Okay, so let's get started one by one. So first, let's go through with the code part, that how things will look like. PubSub stream. Yep. So this will be our target table, first of all, right? This will be our target table where we will be writing the data. But before like writing the data into the target table, we need to look at our, you can say, mock generator, right? The kind of data it is producing, and similar to that one, we will be creating our BigQuery table. We need to define our table in the BigQuery, right? So you can see that we have a very simple basic code, right? We define our project ID and the topic ID, right? So we created one pub sub topic here. So let me show you this thing. Right? So you can see from the Python code, I need to publish the data into the pub sub topic. So I created a topic named as IRCTC hyphen data, right? So that's what I created, and that's what I have mentioned here, that this is going to be my topic ID and this is my project ID. And after that, we have this function which basically generates the mock data like with random IDs, random values. You can see this kind of JSON data it will prepare with row key, name, age, email, join date, last login, loyalty points, account balance is active, insert, updated at, that kind of thing, right? And this is our main function. And here what we are doing first, we are initializing, we are creating the objects for the publisher and the topic path. So this function is there, initialize pub sub. So you can see first we need to make sure that we have the Google Cloud pub sub Python library installed. And this thing we saw when we were working in the on the pub sub itself after the Kafka module. So make sure you have the similar setup here, and exactly same thing we are doing here. So we have created the publisher based on the publisher client. So object of the publisher is created, and then the topic path needs to be prepared. So these two things will be used while publishing the data. Okay. And yeah, now here what we are doing after initializing the pub sub, we are generating the mock data. So generating the mock data here, it is basically accepting an integer number n, means how many records you want to publish. If you want to publish 100 records, so it will generate the list of 100 records, and one by one it will publish in the Kafka topic. Okay. So that's what it is generating. You can see this function is actually returning a list, right? So data is list, and individual one by one we are iterating, and those many number of records we are preparing, and we are creating as a list, and that list will be returned. And then we are calling this function publish to pub sub, and here the publisher, the topic path, and the list of those JSON records we want to publish. One by one, we are iterating on top of them, converting it into this string, encoding them with the UTF-8 encoding, and then we are simply calling the publish method to publish this particular data in the particular pub sub topic path, right? And then here we are also printing the message ID as well. And what we can do here, we can also print our data. So for better understanding, so data and then record message JSON, message byte. So we will print this one, message JSON. Okay. So this is how our mock script looks like. This is how it will feed our pub sub topic. Okay. So pub sub topic is also created. Now after that, the part is to create the to set up our BigQuery table, right? So that our source part is ready and the end part is ready. Then we will focus on the middle part, which is our data flow job, and the way it is going to read and write in the BigQuery. Okay. So this is our BigQuery, and for this one, this is going to be our table schema as I showed you. So this kind of table I have already created, IRCTC DWH, named as 𝗍𝗶𝗶 So this data set IRCTC DWH is created, and currently ignore this table. Just focus on this one, IRCTC stream TB. This is the table, right, which is our target table. We are supposed to write the data, and this is the kind of schema it has. Okay. So till this part we are sorted now. Correct. Now what we will do, we will come here in this thing, right? So here you will see, so this is our data flow, right?
So here you will see these two options, jobs, pipelines. So jobs, pipelines means you can create the ad hoc jobs from here. And now let's say that job could be for the batch data processing, right? Like moving the data, or you are receiving the CSV data in the Google storage bucket, and every day you just want to run the load process on the BigQuery. So batch processing can be done, stream processing can be done. For that one, you will create a job. So job is more like creating the ad hoc jobs. And let's say if it's a streaming job, right? So you will create once, and after that it will continue running it until unless you stop it. Okay. So that will be a one thing. So the point is, when you create a job, there will be no option to, for an example, schedule that job specifically. I'm talking about the job. But what you can do, the job you have created, you can convert it into a pipeline. So when you convert it into a pipeline, then it gives you the option for scheduling, and even to create that sort of lineage itself if needed, right? So first we will focus on this thing, like how we create a data flow job which will actually do this kind of stream ingestion for us. Okay, so here you will see these two options: create job from template, create job from builder. So let's click on this one, and there we will see both of the option, right? So that's what I'm saying. Data flow template and job builder. Build a job with source, transforms, and sinks, right? Here, now the data flow template, it will give all the boilerplate code. We are not doing anything from our side. Whatever it generates, we will be accepting that part, right? There you will see some other, you can say, processing nodes in the workflow it will add for doing all that internal processing, right? So first let's look at this part, and then I will just quickly show you that how the options looks like in the job builder, and how it looks a bit different from the templatized data flow job. So here, this is the, let's say, job name we are giving, IRCTC_PubSub to BigQuery dev, right? And then after that, we will select the region, like in which region this job needs to get created. And now the time is to select the template. So here you can see process data continuously. So this is related to the streaming, I mean stream related. And then process data in the bulk, right? If you want to do the bulk load, so you have the templates for so many use cases. Let me show you itself, like Bigtable. Bigtable is what? Bigtable is basically nothing but the what I should say, Bigtable is nothing but your NoSQL database. So if CDC is happening there, so you want to capture that CDC and want to put it in a HBase, want to put it in a vector search, right? If that CDC you want to push in the BigQuery, those CDC even you want to put in a PubSub, in a cloud storage, in the BigQuery, right? Now you can see this thing, cloud storage text to BigQuery, right? And here you can see cloud storage text to BigQuery with UDF, data stream to BigQuery, Kafka to BigQuery, Kafka to cloud storage, Kafka to Kafka, MongoDB to BigQuery. Like you are performing CDC kind of changes in the MongoDB, and you want to capture it, ingest it in the BigQuery. So tons of things there, right? It depends. It is, this data flow isn't just for the BigQuery or something. Depends what kind of use case you have. So you can simply leverage that templatized code itself, and you can prepare your job here for that kind of data movement from X to Y, some source to sink, and in between if you want to do some sort of transformation itself. Okay, transformation like your filtrations or the column derivations, cleaning, cleansing, all that part. Okay, so those options are here, and that is what we are going to leverage. For us, what we are interested in, right? We are interested in this part. So you can see here in PubSub, we can have a data in Avro, we can have in the Proto. So templates are given for different kind of formats itself. So if you are publishing your data in the PubSub in the Avro form, and then you want to ingest it in a BigQuery, you don't want any transformations in between, etc. Or maybe a transformation not in Python, but in something else. So if you don't move ahead with the Python based UDF option, then by default, what it will ask you, it will ask you to write the transformation in the JavaScript and then upload that file here. Okay. So for us, we are getting the data in the JSON form in the PubSub topic. So let's see what we have for us. So if you come here, PubSub, just a moment, PubSub. Where is that one? PubSub to MongoDB. This one. PubSub to BigQuery with Python UDFs, right? So we are interested in this one, that we will go ahead for PubSub to BigQuery with Python UDFs. Okay. So just click on this one. And as soon as you select this thing, right? After that, it will open this template for you where you need to provide all these information. So first information, you need to provide what is going to be the target table, right? So for us, target table is this one, the IRCTC stream table. Okay. And then this is related to the data encryption. So we will use Google managed encryption keys, right? And then this option, the exactly once, at least once. So we discussed this part during the Kafka itself. So here itself from the PubSub, data ingestion is going to happen in the BigQuery. So we can go for, like, we are interested in the at least once or the exactly once. So at least once means there is a possibility that same data might get ingested in the BigQuery more than once, but with exactly once, only once that record will get ingested in the BigQuery. Then enable stream engine. Now this part. So here, when you create the PubSub topic, topic name is there, and by default, a subscriber gets created for that one as well, right? So here you only need to provide one option. Both options won't be expected. Either you can provide the topic name, right? Or you can simply provide the subscription name. Any one of it you can provide. So let's say we will provide the topic name. So this is our topic, IRCTC data, right? Now from here, your optional parameters related to the infrastructure setup of your pipeline, because as I said, right, behind the scenes, that is going to be your Apache Beam, who is running all this thing. So that needs to get executed on some compute engine. So some resources we will be defining here, or we can go for the auto scaling, right? All that part we will be doing. So before doing that part, let's start looking at this thing, the optional parameters. Table for messages failed to reach the output table, right? So in this case, let's say you have created a different table, right? You have created a different table where you basically want to write the, let's say, those kind of records which was not able to get ingested successfully in the BigQuery, right? That's what table for messages failed to reach the output table. If they were not able to reach the output table, you want to write it somewhere else, means into another table, into just raw form, in the raw string, not even a proper structure or something, right? So in that case, you can simply create another table, maybe with one field named as message, and just dump that entire message in the string form, that so that you will have the idea this message was not able to reach my target BigQuery table. Okay, so that option we can give from here. Now, currently I'm, let's say, more interested into these two parts, right? So as I told you, right, you are publishing the data in the like byte format to the PubSub, okay? And from there, you are going to read it in the you are going to ingest it in the BigQuery, and in between, let's say you want to do some derivation, some transformation. So for that one, what we will do, we will write a Python code. It has a specific, like should be a simple function you need to create, and then you need to come here and register it. That's the thing you need to do. So let's look at what kind of transformation method we have. So we have a Python code, and the file name is transform udf.py. So what we are doing here, right? So we are simply doing it in this form. We have created our own function name, transformed data. By default, it will accept this thing, element, as a input argument. And who will pass this element? So your data flow job, as I said, it is a streaming job. It is a streaming job we are creating. And when we say the UDF means individual record, which are coming in the data flow job, those have to go through with this transform data function. It's a UDF kind of thing. So on every JSON data record we are getting, this transform data will be applied. So this element is nothing but that you can say input JSON record we are getting from the PubSub. So here you can see we are doing, we are not doing some we can say we are not doing some heavy transformations, just like we are making cosmetic changes in the data which we are getting from the PubSub and deriving some values and fields there, and adding some extra values by populating it. So you can see we were getting the data in the string serialized form, and we are using the JSON.loads, which will convert into a proper JSON object. Then from this data, we are fetching the value of row key. If it is not there, we are populating it with the empty value. Then we are trying to fetch the name value, and we are simply making it in the capital form. And then we have our email. We are applying the lower function to just put it in the lower words. And then is active, right? By default, we are trying to get this value. Let's say this is not there in the object, right? This is not there in the object. We are putting it there with a default false value. Then we are doing this kind of data enrichment, like the loyalty status. So platinum, if loyalty points greater than 500, right? If not, then standard one. After that, we are populating the inserted at kind of column, updated at kind of column, right? And then we are also populating this column, account, age, days, and then working on these columns like age, account balance, loyalty points, last login. So a kind of like we are trying to form it in the expected JSON. With respect to that one, we created our BigQuery table. So the kind of data, let's say our mock Python script in the PubSub topic, it was publishing the JSON object with 50 fields, right? But in my target table, right? In my target table, I am only interested in the 10 fields, right? So what I need, definitely I need some sort of transformation in between, right? So that picking up only 10 columns is just one use case. Maybe we wanted to do some more data cleaning, some more data derivation, new column addition, whatever it is, right? As per our target table. So all those things we are simply doing in our transformed UDF method, which we have created, right? And then after doing that part, we are again converting into the string form and returning it. So that's how it will move from the data from like the transformed data to the BigQuery. So transformed data UDF will be called by the data flow. In every individual record will be passed here. It will be transformed, and then after the transformation, it will be returned back, will captured by the data flow, and then this transformed record will get ingested in the target table. If there is no problem, maybe let's say there is some data type mismatch. Maybe in your transform code, there was a column named as the age, right? In your BigQuery table, you have defined it as an integer. But here in your code, you somehow put that value in the string form. So this particular record will not able to get ingested in the BigQuery table. In that case, it will be failed and it will be written somewhere. How you can find that one and how you can get to know what is the exact error, I will talk about it once I will set up the data flow pipeline. So this is the code we have written. So what we will do, we will basically make this code available in a bucket. So we have created this bucket, BigQuery projects, let's say, and inside that one folder pops up to BigQuery, right? And here we have this transform udf.py, right? So this is the code which we have put it here. So this is what we are going to use now. So let's come here. So we need to provide the path for our UDF. And then you need to provide the function name itself. Like this is our Python code. So in this Python code, there could be 5, 6 functions itself, right? But which one is something which is going to act like a main calling function for this Python UDF. So this is the name, transformed data, right? Now, what is this staging location? Right? Staging location is nothing. So when your data flow works, it is doing the stream processing or it is any batch processing. So in between whatever intermediate data it generates or it, let's say, reads somewhere and it feels that I need to put this data somewhere, the intermediate data. So here what we can do, we can provide the GCP bucket where this intermediate data should get written, right? So that path we can provide. Let's say by default, we are not providing. So it will create a default directory. It will create a default bucket itself and all the folder structure and automatically it will handle that one. But if we have created our own, we can provide that thing here as well, right? Now here, if you want to go for the auto scaling algorithm, so you can follow the documentation page and you can put any specific auto scaling algorithm you want. But for our case, we are in the free tier. We will go ahead with the fixed number of workers, right? So let's do that. How we are going to do it? So number of workers, I will put 1. Maximum workers, I will put 1, right? Now disk size. Disk size, we will try to keep it 32 GB, right? And then you have multiple other options which are related to your application, right? Data flow will dump heap on and out of memory error, right? So here you can mention that property in case of the out of memory. So whatever data is there, ultimately you get the out of memory when your heap memory is getting filled in, right? So if that kind of error is coming in where it should basically put this dump this heap data, so that you can provide here. Data flow will dump heap on out of memory error to supplied cloud storage path, right? So that path you can mention here, and here you can provide this value which is related to this part. This should be a value property. Data flow in GCP doc. What value should be here? Will dump heap on and out of memory error. What is the value of this? data flow in GCP. BigQuery to see this one. Out of memory, we have okay, well, even they have not mentioned in their document page. Weird. Anyways, let's move. I will check what value we actually need to provide, either some threshold value that this much of memory for the heap, and after that it will be out of memory. And if it happens, then we need to write the data which is exceeding in the heap memory to this particular location. So I'll check like what value we need to provide here, because the placeholder they have put it is not clear at all from here, not even any information icon. Now, log level to use the data flow, like when your data flow job is running, what log level you want to put, like info, debug, error, warning, that thing. Zone, if you want to specify the zone, like the worker, wherever. So these will be the workers, like another commodity hardware. So in which zone, in which region, under which service account email they should get spawned up. So all those values we can provide from here. Right, if you are not putting anything here, by default these things will be taken care by the data flow template itself. You don't need to bother about it. Similarly, for the network itself, if you want to spin up these resources under any specific network, you have created the VPC network, so you can provide that network, sub network, IPs, any temporary location, right? All those things you can provide here. So these properties, we will keep it as it is, right? And the important one which we were uh, needed for this one, like the template and these properties and our pub subtopic name. After that, the UDF location and the UDF Python function name. Apart from that, we provided the worker related details. So apart from this, whatever we are keeping it as it is null or empty, data flow job will take care of it automatically, right? And that part which I'm talking about, where the fail records will be written, how you can look at that part, okay? So that I will show you as well once we will create this job and set up this job. So now I will run this job. It will take a couple of minutes to spin up, and then we will start publishing the data and we will look at it. It takes 4 to 5 minutes to warm up the entire cluster, the job, the worker nodes, etc., and then start working on it. Okay, so let's click on this thing, run job. So as I said, from here, this is going to be the streaming job. Once you create it, it is a streaming job. It will be in the running state until unless manually from here you basically stop it or not. Okay. But once you stop it, and here you cannot see any specific option. If I even do this thing, right here, it is giving the trigger option. Like once this job completes, what you want to do, you want to run the cloud function, cloud run. So sending the notification to those ones, that is the thing will be there, but you won't see any option to schedule this specific job or re-trigger this job, right? That is the thing, right? So once you stop it, there won't be any option to even just re-trigger this job from here. You can clone the same job, you can again run it. But the point I was talking about, if you want to have that control of re-triggering it, scheduling it, you have to convert your job into a pipeline, or probably set up your flow which you wanted to create here in the pipeline itself. Then you will get that control there. So let's go in the logs itself. So here you will see that it is printing the job logs. So it will take some time to set up all the code, because here you have picked the template and you have provided the source detail, sync detail, UDF related detail. It will have it now. It has all the information. It will basically set up your Apache Beam code and wherever it needs to place, because that will be a code. By default, it will create some bucket and directories there. It will put that Apache Beam code there and it will run in the stream form, right? So that sort of setup it is doing, and a kind of lineage will get created here once the job setup is done, right? Here you will see a lineage of this particular streaming job, that from where it is reading, what it is processing in success, where it is writing in failure, where it will write. So there will be multiple stages, multiple nodes in this, you can say, in this uh, workflow, right? When this lineage will get created, and those will be basically for the internal processing for this Apache Beam job. Okay, so that will be there. So let it first finish, and you can see here Python SDK container image set to Apache Beam Python 3.11, right? So under the hood, it is going to use the Apache Beam. Okay, so give it a moment to complete it. All right. As you can see, it is in the running. Running means still it is doing some sort of setup, but now you can see this lineage I was talking about, right? So read pub subtopic, and then it will do some serialization, deserialization in between, write successful records, right? And then if we would have given some location, the part I was talking about for the fail record. So here it would have gone, but successful write, let's say it was doing, and during the write part, right, it is not able to do that. Internally, it will try to handle it, but how it will handle it and how it will do that, I will show you once the worker logs are spinned up. So what happens basically, I will show you, because earlier I had some failed jobs as well. So while that, by the time it is processing it, right, so almost it has done the setup and all those part. So in couple of seconds, our worker will also be up and running. Okay. So I will show you that when we will be setting up our job pipeline for the first time. So whatever is the sync, right? So let's say you are trying to ingest the data in the BigQuery table. So the point I was talking about, since we did not configure any table that where the fail record should go to, etc., etc., it will try to create a table to process the failed messages along with the error, all those information. So that will be the responsibility of the workers. As soon as workers pick up the task, right, try to process the data. So what it will do, it will try to create a table, right? And that is the reason you can see one table named as this IRCTC stream TB error records. Okay. So in this case, if I show you the preview of this table, how it looks like, right, it will automatically get created. I did not create it at all. When my worker started running, as soon as I published one record in the PubSub topic, it tried to read it. There was some issue in my transformation code, so it was not able to transform it properly, right? So it was not able to ingest in the target table. So where it did, it basically created a table because we gave that permission BigQuery admin kind of permission, right? So now you can see our worker is also initializing. Okay. So it is also initializing, and here again you will see the option. So what it does, it will try to create the table if it does not exist. Let's say we created some specific table, we already configured it while doing the setup for the data flow pipeline. It will use that one if you have not defined anything. So it will create it like this: timestamp, payload string, payload byte, attributes, error message, and complete stack trace of that error. So if I show you the preview, right, this is how it will look like. So you can see I basically tried to insert this data, right? Earlier I can show you. So you can see I tried to insert these records. This was the byte form of it. And you can see here, this was the error message: failed to serialize JSON to a table row. There was some issue was with the serialization part, and here you will get the complete stack trace of it if there is some specific error, so that you can debug it. So if I come to our data flow, let me see if try create it. If table is already existing or something, then it will not attempt to do that, right? Because it is already there. And now this is also almost done. So what I'm going to do now, currently, let's say, let me see if I have some records in the target table. So I will delete it. So let me run it. Yeah, so two records, I will simply drop them. Truncate table. Okay, so table is truncated. Now it is empty. And if I go to preview now, we should not see anything. So it's empty now. Okay. And now the time is 2. So worker, all right, it is running fine. There is no issues. You can see it's a continuous running job. It is listening to what we have. And apart from that, the things which I was telling you, right, that it will create these jobs, right? This is going to be the complete pipeline URL, and staging location, temp location, right? It basically created everything on its own. The locations for this one, files to stage, different template code, which is basically created, right? So all the jar files by default it needed, whatever it was needed there for this template code to execute this data flow pipeline, it had everything, and your pipeline is up and running. But let's run it first. Okay, so what I'm going to do, I'm quickly going to insert one record only. For an example, you can see generate mock data, right? So this one, we will publish one record, and after that, we will generate couple of more. IRCTC mock. So this is the data you can see with row key F2 something something name is this. This has been published, right? So let's refresh here, and let's also look at our data now, refresh it. So you can see we have our data which we inserted, this row key F20 something, name, age, whatever we wanted, right? So that's how we will be getting. And maybe in this case, what I will do, for an example, I will put, let's say maybe 20 more, and let's run it. Okay, so it has published all those 20 records. Let's see, is there. So by any chance, let's say because of any reasons, let's say there was some issue in your job setup itself. So the way you are looking at the logs here, right? You can open up the logs as per the error, or you will be able to see the way we are seeing the warnings here. Similarly, you can see the logs and in the diagnostic itself. By any chance, your write is failing, permission issue or anything, so the logs related to your pipeline you will be able to see here itself. Okay, so that you can fix your pipeline. Let's see here again in our BigQuery. Let's refresh it. So how many records we have? 21. One we ingested earlier, 20 we ingested just a moment back, right? So this is how you can see the way you created your pipeline. It is just getting the data from your streaming source, replayable source, in between applying the transformation we did, and then syncing your data in the desired form in your BigQuery table. Now in the streaming form, data keep on coming here, and you can even create a real-time dashboard if you want to use the BI engine here, the integrated visualization of the BigQuery, or maybe any other like Tableau, Power BI, whatever it is. Okay, so that is how it is going to be. And now the point I was talking about, this thing, right? So you can see this option, create the clone, right? Create the snapshot of this job, right? So snapshot like keeping the checkpointing part sort of thing, right? So that next time maybe you clone this job or you set up the pipeline for this job itself, right? So it will start from that point. And here you see the option for the stop. Okay, so even as I said, there you won't see any option specifically to re-trigger this pipeline, but you see this one, create a new data pipeline based on this job. So this job, when you are converting it into a pipeline, so same template will be there, and there it will give you the option. Let's say it's a streaming one, so you only need to probably trigger it once. But let's say it was a batch job where you are getting the data from the GCS table based on some file pattern, and then every time you are loading it into a big query, then in that case, obviously you need to trigger it maybe once in a day or something like that. So you need to schedule it. So you can import it in the pipeline and you can put a schedule there. So if how to stop it, basically you can see, click on the stop. Here you will see three options. So this one is grayed out. You can see force cancel is only available if job is stuck, cancel or updating for last at least 30 minutes. So these two options, cancel means it will do the abnormal termination, right? It will not basically care about the existing running process or etc etc. But there is another option, drain. So drain option, it will seize all the data ingestion but will attempt to finish processing any remaining buffered data, because right, it is getting the data continuously in the stream. So obviously buffer will be there, like once we poll the data, so based on that one, if there is some data in the buffer, it will finish up executing that one. And graceful shutdown, you should go for this drain option. And for forceful or maybe without caring about the remaining data which you had in the buffer, you can go for the cancel one. So let's click on the drain and just stop this job. So there is nothing in the buffer, right? So it will get stopped in just 1 or 2 minutes.
So this is what I had for all of you in this amazing video. If you enjoyed, you found it informative, you like this project, you implemented it, if everything was good, then make sure to give it a like and share it with your fellow aspiring data engineering friends. make sure to add this project in your resume as well, implement it end to end. And if you're new to the channel, make sure to hit the subscribe button and press the notification icon. I will see you guys really soon with another amazing video. Till then, just keep exploring data and don't forget to enroll yourself in my high quality, most affordable and industry oriented bootcamp, which is data engineering bootcamp with AWS, where you can learn the entire data engineering from basic to the advanced with open source data engineering tech stack plus the cloud services with the dedicated placement assistance and the doubt support. The link has been given in the description, or you can visit www.growdataskills.com. For any kind of query and questions, you can give us a call on this number and we will help you.